Okay, so the nitrogen cycle is our topic. Some of the objectives of this unit, one is to describe nitrogen cycling. Again, our curriculum is more geared towards agricultural systems, but this can be applied to any system whatsoever. Nitrogen cycle is a fundamental, what we call biogeochemical cycle that occurs in all ecosystems, forests, ag, rangeland, okay, what have you. We want the students to be able to identify the major processes in the nitrogen cycle, and again, how much detail you put into that will depend on your level, what topic it is, the age group of the students, if you want to go into the full-on chemistry of it, or just talk about the processes and maybe where do you have that process occurring, when is it favored, when can the students predict that it will occur. Describe the relationship between agricultural crop productivity and nitrogen. Obviously, nitrogen is a huge component when we start talking about sustainable ecosystems. Right? If we have to continue to have large inputs of nitrogen from outside sources, that could be a problem given that nitrogen, of course, is tied to fossil fuel. So the price of nitrogen deviates with the price of fossil fuel. So there's all of these reasons, plus all the environmental impacts of nitrogen, why we focus on nitrogen as a component of building these more resilient, sustainable cropping systems. Describe the reasons why nitrogen application in excess is harmful to the environment. We'll talk a little bit about that. And identify ways that nitrogen moves into and out of the soil. So how may it actually leave the system? How does it come into the soil system? Okay, so here's where we do your pretest. Okay, so the first question is, nitrogen is the most limiting and over-applied nutrient in agricultural systems. And I've been told that I have to hit this box. Oh. Yep, polling is open. 13, 15.
And you have one there for missing person.
Oh, now I'm at 16. Great. Okay, so 14 of you said true, 2 say false. All right, so the majority of you have that. Nitrogen is the most limiting nutrient in terrestrial systems commonly. And that's not just all systems, that's all systems across the board really, but especially in our agricultural soils where we're trying to maximize crop growth. And it is often over-applied. There's insurance fertilizer that we sometimes see applied to our agricultural systems, right? Just in case we have the best rainfall and the best temperature and we're going to get our maximum yields in that year. That's the level that we're going to fertilize to. So that does happen. Okay, so good job there. Okay, next question. N is essential for plants because it is part of A, lignin, B, water, C, enzymes and proteins. Okay, good. 16. Okay. So you can find nitrogen in lignin, right? But that's really not one of the essential biomolecules that is present in the plant that carries out things like photosynthesis or proteins. So enzyme and proteins are the correct answer there, which overwhelmingly you guys know, which is awesome. Okay, next, the atmosphere is about 78% nitrogen. True or false? Excellent. That's right on, right? There's about 78% of the atmosphere is nitrogen, which is really interesting, right? Because I just told you that nitrogen is often the most limiting nutrient in terrestrial systems. So we're literally bathed, our plants are literally bathed in nitrogen, yet it is the most common limiting nutrient, right? And that's because the form of nitrogen in the atmosphere is N2, N triple bonded to N, which is a very inert form, so most plants can't access that. Well done. Next one, plants generally utilize which of the forms of nitrogen? A, B, or C? Need one more. There we go. All right, good. So most of you got that. The answer would have been ammonium and nitrate. Those are those inorganic plant-available forms of nitrogen that most plants can access and take up. So most of the nitrogen in the soil, usually about 98% of it, is actually in organic form, but that's largely inaccessible to plants. Although we know there are some mechanisms that plants can use to actually take up that organic N, it's not that common. Okay, next question. Oh, okay, good. What is the largest source of nitrogen in agriculture? So where do we get most of our agricultural soil nitrogen from? Waste, lightning fixation of N2, symbiotic bacteria, or fertilizer? You guys have all done it, right? Fertilizer. We didn't trick anybody on that one. That's true. Lightning does fix N2. Fix, with that term fix, means that it's converted to a more reactive form. So that does happen, that's a real thing, but it doesn't fix a whole lot of nitrogen every year. Right? So if you've ever heard that old wives' tale, you should plant where there's a lightning strike. Right? There is actually a little bit of truth to that, where lightning does create enough heat and energy where you have that N2 converted to a more reactive form. And then animal waste, of course, is an important source of nitrogen, but primarily we see that in our organic systems where they can't use synthetic fertilizers, or in areas located close to dairies where there's a large source of animal manure. Okay, next, nitrate is safe to have in drinking water. True or false? Waiting for one more. There we go. Okay, so nitrate is a known contaminant of groundwater. There is an EPA set limit for nitrate in our drinking water. 14 of you got that right, so that's great. We do have to be careful about this. Nitrate is an anion. It has a net negative charge, and so do most soil materials. So they repel each other. So nitrate is free to move down the soil profile with water and can enter groundwater. Okay? Now most of our drinking water is very safe. I think it's probably more dangerous personally to eat hot dogs than to drink most of our groundwater, but it is a potential concern for infants primarily, although we do know very little about the human health impacts of long-term chronic ingestion of nitrate levels. Next question. Denitrification can produce greenhouse gases such as N2, dinitrogen gas, NO4 gas, or N2O, or nitrous oxide gas. Okay, some of you are going back here a while. You're trying to review the nitrogen cycle in your brain. Okay, right. N2O is a product of the denitrification process. Denitrification is that one that occurs only in saturated soils where water has displaced the oxygen. So organisms that are capable of doing it will actually switch from using oxygen as a terminal electron acceptor to nitrate. So we see nitrate going into the atmosphere as N2O, and potentially all the way to N2 gas during denitrification. So this process happens because of saturated soils, and we have organisms that can switch terminal electron acceptors and use nitrate. Okay, next one. Ammonia gas is more likely to be produced when A, nitrate fertilizers are incorporated into the soil, so a nitrate-containing fertilizer, like potassium nitrate. Ammonium fertilizers are applied to the surface of soils. Our soils are acidic. A little bit more of a mixed response here. So this process is called ammonia volatilization. Okay, and those of you who are around where you have a lot of dairies, you're used to this process because you can smell the ammonia gas when it's released from the soil. So it just so happens most of our soils in Idaho, where we have a lot of dairies, are actually alkaline soils. Down south, they're not very acidic, and this process is favored by higher pH. So C is out. Right? It's not that important of a loss of nitrogen in acidic soils. It's more important in alkaline soils. Ammonia is really one of the main reactants in this reaction. If we were to draw it out, we'd have ammonium in plus hydroxide ion in equilibrium with the products, which is ammonia and water. So ammonium is more apt to lead to ammonia production. And that's a nice reaction to talk about. That's a simple equilibrium reaction. So if you draw it out and you talk to the students about, all right, if you increase the reactants in this equation, it's going to go to the right. If you decrease the products, it's going to go to the left. So you can predict which way the reaction is going to go. For those of you that teach more chemistry-based